Well, good morning and welcome to the Blazor Desk Show. I'm Carl Franklin in an all-new studio here, ready to show you what's happening in Blazor land. Yes, we're going to be talking about Microsoft Blazor today. Hope everybody is safe and healthy and happy. Yes, I am Vice President of AppVNext. We're going to be spending a couple hours this morning talking about the ins and outs of Blazor. Server side, client side, all of them. Both of them. But before we start, I really want to give a big shout out to our sponsor, DevExpress. DevExpress has been in the business for, wow, a long time, 20 years, at least 20 years. They started with Delphi controls and worked through Visual Basic controls and then up to, of course, .NET and all of the things there. And now they've got some free Blazor controls that they'd like you to check out at devexpress.com/freeblazor. And I hope that by the end of this talk, you will see the value in what they're doing. It's pretty amazing. All right, so here's the agenda today. I'm going to share everything I know about Blazor. Get ready because it's going to come fast. But don't worry about missing out. If you don't feel like you have to take screenshots of the URLs and stuff, because this PowerPoint presentation and a hands-on lab that brings you through developing all the software that I'm showing you here, plus the code itself, is all downloadable online at blazordeskshow.com. All right? Very cool. So let's talk about what Blazor is. Blazor started as a project by Steve Sanderson where he wanted to run C# on WebAssembly, which is a browser technology. It's a virtual machine, and it's built into every browser. And so he did this little project, and everybody a couple of years ago at NDC Oslo was blown away. And they were like, oh my God, this is amazing. So there's a new technology in the browsers in the last couple of years called WebAssembly. But it evolved into a component model. And the component model simplifies development for web, for a sort of a web technology for UI binding and event handling and all of that stuff. Simplifies development. And so that same markup, HTML markup with C# code, can run in one of two hosting models, but you got to pick a horse. The first one is running in the browser on WebAssembly. The second one is you can actually run that same code on the server, and there's some magic that happens in the middle there, and we'll talk about what that is. Here's the cool thing. The same markup and code will run in either hosting model. You don't want to combine hosting models, nor would you want to, because this is a SPA framework for user interface, okay? So essentially you're binding user interface elements to code elements, and when those code elements change, the user interface changes. So in the way that works, you don't want to, you can't mix and match. You're either that UI code is either going to run on the server or it's going to run in the client. So the number one question I get from people who are kicking the tires is, hey man, this is just Silverlight, right? This is just the next version of Silverlight, isn't it? Excuse me. Still morning here. No, it's not Silverlight. The only thing that is the same about Blazor client or Blazor WebAssembly and Silverlight is that C# code runs in the browser. That's the only difference. I mean, that's the only similarity. After that, it's completely different. Silverlight essentially got into the browser with the plugin model, and the plugin model turned out to be really a problem. Well, it was a problem for one guy in particular, Steve Jobs, who at the time was battling malware on the iPhone and the iPad for the first time. And it was all coming in through Flash. Well, it was actually through the plugin model, and Flash was a big vector for that. Flash was also stealing a lot of CPU cycles for iPhones and iPads, and it was wearing down the battery. And so it was a bad deal for them. And then Steve Jobs basically said, no more plugins, including Flash, including Silverlight, but it was really a problem with Flash. So there you go. WebAssembly I'm going to talk about a little bit more, but you'll see that it is not an insecure platform at all, nor is it going to cease to be supported. It's here to stay. Now, if you want to, we're going to talk about this Blazor server hosting model and the Blazor WebAssembly hosting model. You can build a Blazor server app right now just by installing and running Visual Studio 2019. You don't need preview. You can use the finished version, the shipping version of Visual Studio 2019 for Blazor server. For Blazor client, however, that's still in preview. And you need to do a couple of things. You need to install the latest .NET Core SDK 3.1, install the latest Visual Studio 2019 preview, and the Community Edition works just fine for both Blazor hosting models, which is the Community Edition is free. And then you install the Blazor WebAssembly template. And if you just Google Bing Blazor WebAssembly Preview 3, you'll find this URL. And it has detailed instructions for you. Welcome, Brazil. I'm drinking some of your juice right now. All right, so what is the magic that makes Blazor work on the server and all that code run on the server? Yes, it is SignalR. Unlike traditional AJAX calls where you make calls for data and stuff like that using an HTTP request and then get an HTTP response, normally in JavaScript, that isn't happening. There's, at some level it's happening, but you don't ever touch that code. A SignalR hub has injected itself into the middleware here, and it's just part of .NET Core. It's just right there. When you make a Blazor server application, you get a SignalR hub, and that SignalR hub maintains a persistent connection between the server and each client, okay? And it's a one-to-one connection here. It's a one-to-one communication, not a one-to-many, like many SignalR implementations are used. SignalR is canonically used for chat, right? Or notifying all the clients that something has happened. Well, in this case, the SignalR hub is just for UI updates, right? So it's just going back and forth between the server and the browsers. Let me jump over to Visual Studio, and we'll actually create a Blazor server application here. I'm going to call it Blazor Server. Now, because I have installed the WebAssembly template, I get the option here of making a Blazor WebAssembly app, but I'm not going to do that. I'm going to use I'm going to create a Blazor server app. And I'm just going to run this default project. Out of the box, we get this little demo. That's pretty cool, actually. And here it is. So we have 3 pages. We have this home page that has some static information. We have this counter page where we actually get a button and we can click and it updates a counter. And we get this fetch data, which gets some data from a service. So let's look at the code for the counter page because that's interactive. And this is, more along the lines of what you would do in a spa. And take a look here. So this is just some HTML. And I've got this paragraph here. And using the Razor syntax, I'm displaying the value of this integer property. It's not really a property, it's a field, but there you go. And then when I click the button, you see this @ on click. The @ denotates that this is a Blazor click event. Calls this increment count, and increment count updates that counter. I can put a breakpoint here, and when I click the counter, I'm in code, and I've got I can debug and do all that stuff. It's really cool. So it looks like magic. I mean, you don't see any plumbing code here. There's none. So what's actually happening? Wouldn't you like to know? First of all, I'm going to show you this page right over here, _host.cshtml. This is your default route. So you can see there's some HTML here. And we've got, oops, that's not what I wanted. Hit the wrong button. You can see we've got some, a header. And then the whole of your Blazor UI and code is right there in that little app. That's where it is. All the rest of this is for handling errors, but you also have this guy right here. Look at this. Script. So this is Blazor JavaScript. Okay, so this is essentially hooking the DOM and doing all this magic for you. Now what happens when you click that button is that that JavaScript sees that there's a button clicked, and it sends a message through that SignalR hub to the server that says, hey, the user clicked that button. Now we know that this @onClick is supposed to call increment count. So Blazor runs this code, this method, increment count, and then it takes stock of how that has affected the UI. And it does this because there's a model of the DOM on the server. There's a model of the client's DOM, and it's really a graph. All right. So what's happening here now is we execute the code, and then we look and see how it has affected the DOM, and takes a diff, and any differences or any changes to the DOM get shipped up in a binary message and send back to the browser, and it updates the DOM. Let's actually watch this happening. So I'm going to press F12 here and get the network tools. And also notice that my cache is disabled. I want that because I'm going to watch the network traffic here. And we'll go to the counter page, and I'm going to press Control F5. And Control F5 is going to reload the page, right? So not a whole lot of stuff was transferred. 146K. Whoop. Not a whole lot of data. Let's look at it though. In particular, and let me expand this. In particular, check this out. This underscore Blazor question mark ID equals blah, blah, blah. That is a WebSocket. That is the connection to SignalR. So I'm going to clear this, and I'll click a button, and let's go look and see what happened just now. Well, we know that 290 bytes were sent up to the server, and then it came back with 148 bytes. And that is essentially the server saying, hey, update this section of the DOM. And then we sent back 27 bytes with just a sort of a, okay, thank you, everything's good here, right? Now you can also see these little 3-byte messages that are ongoing. Those are just, you know, health checks, essentially. Just pings. All right, so first of all, I want you to take a look at this URL down at the bottom here, Advanced Logging of SignalR. That is a blog post that I wrote that tells you how to actually look and log all of the traffic look at and log all the traffic that's going over SignalR. So you get more than just, hey, a few bytes were sent, right? All right, so let's talk about scaling, because this, you know, is the issue. When code runs on the server, there's a certain amount of overhead per client, and it's estimated to be at about 85K minimum server memory required per client. Okay, now that doesn't take into account any of the data that you're serving, so you have to add all that on top. And what that means is that if you want to be most efficient and support the maximum number of clients that you possibly can, you want to keep that memory at a minimum for each client, right? So that means whatever page you're on, don't load a million records, put it in a list and send it down to the client. Because that not only means that's a lot of data that they have to sort through, but it also means that it's memory that is required per client, and it's going to decrease the number of clients that you can support. Also, WebSockets are a critical resource that you have to be careful of depleting. And the number that you have is based on memory and CPU. So if you want to, you can move that SignalR out of the server that is hosting your Blazor server app and use Azure SignalR service. And so that sort of takes it out of the equation. It's also good if you're doing a cluster, because now that SignalR service can keep up with each client no matter where they are. There's a nice little, there's a URL to a nice little GitHub document that shows you exactly how to do that. All right, so this slide I stole from Dan Roth from .NET Conf, and they basically did a test, they being Microsoft, did a test for appropriate latency, which is less than 200 milliseconds when they click a button, from when they click the button to when the UI changes, under load. And this was an application that they wrote, a real application. No, today is not just basics only. Rick, we're getting into it slowly. It's 2 hours. So they did a test, and they wanted to see, based on the size and the CPU load of that server, how many clients they could support. So with one virtual CPU that had 3.5 gigs of RAM, they could support 5,000 comfortably concurrent clients. And if they up that to 4 CPUs and 20,000, 4 CPUs and 14 gigs, they could support 20,000. Now that is without SignalR service. That's without any other performance tuning. And this was a real application. This wasn't just counter. And I think they said that their overhead was $165K per client. So that's pretty good. But it means that memory is the bottleneck. If you want to just run it on one server, make sure you have enough RAM and CPU to support the number of clients that you need. All right, so let's talk about the upsides and downsides of this hosting model, Blazor server. On the plus side of the ledger, download size is small. It's smaller than if you were going to load a Blazor WebAssembly application. Loads fast, as you saw, 149K, boom, in our little sample. The app is also running on the server, so you get all of the things that come with server-side programming, access to all of the .NET Core APIs. You can call into services that require authentication because you can, the code isn't exposed to the browser. Also, clients such as Internet Explorer that where they stopped updating before WebAssembly, right? They don't support it. So that's a good, if you have a lot of clients that use Internet Explorer 11, they can run a Blazor server application with a polyfill. Caveat there. And this is important to some. The client can't look at your code because it's running on the server. I'll talk about that in a minute. It's a plus side for some, but I don't really think it matters all that much. On the downside, there's added latency because you have this extra network hop for SignalR for every UI interaction. Okay, you still have to go to the server, to get your data, but you get it when it all stems from a UI interaction, a button click, a list box selected item, something like that, a checkbox. Those things kick off the process. There's no offline support. So that is important to some. If your if your client's internet goes down, their app stops working. So, and then scalability is a challenge, as I mentioned in the last slide. You have to worry about that. Also, you do need an ASP.NET Core server to run this. You can't just take the static files like you can do with a WebAssembly application and ship it off on a CDN. So before we go on, are there any more questions about this? There's a couple of guys from Developer Express in the chat rooms, and they have been answering your questions. Paul Usher is here from Australia. John Martin is here. He's in Florida right now. And I think Don is here. If he's not, he will be soon. Don Webier. But let's see. Is this the presentation part of the Live Coders Conf today? I don't know what that is. The Live Coders Conf. Oh, there's Don. All right. Well, if you have any questions, just put them out in the chat and we'll make sure that they get answered. Okay? Let's move on to the client hosting model. This is a bit easier to understand. The code is downloaded and runs in the browser. Now, let's talk about what WebAssembly is really. WebAssembly is a virtual machine. It's a cross-platform virtual machine. It's supported by every browser that is keeping current with browser technology. Yes, even Safari on iOS devices. Your iPhone, your... I was actually just running, I just wrote an app last night, a Blazor server application, and launched it. And it hosts a SignalR hub. And I wanted to do some live PowerPoint control from a web browser on my iPhone. And it worked just great. So this WebAssembly is essentially another virtual machine. Think of it like Windows. Windows is an operating system. Think of it as like a little operating system. And there are a lot of languages that have compilers that run in WebAssembly. And you'll see they have a .wasm extension. So in Windows, we have a .exe extension. In WebAssembly, it's a .wasm extension. And there are a lot of languages that run on WebAssembly, not just C#, but Rust runs there, Golang runs there, Python runs there. The list is growing, and it's big, and everybody wants in there. So the other thing I want to mention is that WebAssembly supports these binary things, but in the case of Blazor, the only thing that is compiled to WebAssembly is the CLR. So it's a mono version of the Common Language Runtime. And then on top of that, it's managed code, so it's running assemblies. And those assemblies, as long as they're .NET Standard 2.0 compliant, they're going to run just fine. So let's do what we did before. Let's watch the traffic with the network tab of a Blazor WebAssembly app. And I'm just going to add a new project to my solution here. So we'll have them both in the same solution. And I'll call this Blazor WASM. Now you're going to see a nice little undocumented feature of the latest preview of Visual Studio. You'll see a few things like this. The latest preview of Visual Studio still has a couple of brain damaged parts, but those will get fixed, I'm sure. You'll notice that Blazor Server app is my only, somehow is now my only option. If you go to .NET Core 3.0 and then back to .NET Core 3.1, it comes back and it's happy. Now notice a couple of checkboxes down here, and this is just new in the last week or two, last week. There's a new drop, preview 3. Man, sorry, sounded like Max Headroom there for a minute. So look, progressive web application support. So that means if you check this off, You're going to get a manifest. You're going to get a service worker. And it's going to be very limited, but at least you'll be able to install it on your home screen, on your phone or your desktop if you're running an operating system, a desktop operating system. Then also, there's this guy, ASP.NET Core Hosted. And I'm going to check that off, because if you don't check that off, you get one project, just the client app that's going to run in the browser. But I want a server app to also work with this. And take a look at this, if you will. I'm going to scroll in here. I'm going to zoom in, and you'll see that I've got, here's my client app that runs in the browser, Blazor WASM client, and here's an ASP.NET Core 3.1 server that hosts that client, right? So it has a server that the client can call back to in the same space. So look, we've got controllers right here. There's actually an API controller in there that the client calls. And then there's this shared project, and the shared project is where models go. And you can see the weather forecast model is in that shared project right here. It's because the client needs to know what that is, because it's going to display it. And the server needs to know what it is, because it's going to serve it from the controller. So what we'll do is we'll set Blazor WASM server to be my startup project. Yep, there it is. And we'll just run this again. Now that Blazor WASM server is going to load and host in the browser. Well, it's going to load this project here. Now this is WebAssembly. You can see it says Blazor WASM right at the top. And I'm going to do what I did before, which is press F12 and get the network tab up here. Let's expand this a little bit. I'll go over to the counter. I'll disable the cache, start recording, and press Control F5. Well, that's a bit different, isn't it? You can see 6 megabytes were transferred. Now, why 6 megabytes? In the last preview of Visual Studio and the WebAssembly template, it was closer to 2 megabytes. It was 2 megabytes. Well, the reason is that in this preview, they turned the linker off for debug mode. And when the linker is on, it stubs out all of the parts of the .NET framework that aren't actually used in the code. So if you want a more accurate representation of what would be served to the client, let's go to release mode and do this again. And let's see. Blazor server could be good for our semi-internal website that allows users to manage the data lake. Yeah, that's right. Yeah, and I think you say I have some convincing to do first. I think a lot of people are in that same boat, my friend. That the technology is great, but especially convincing management that has gone into Angular or React or Vue and embraced JavaScript. It's a hard sell, or it can be a hard sell. Others get it and are like, oh, you have to do this. All right, so let's go back to the counter. Start recording, press Control F5. And now it's only 1.9 megs, right? So what actually got transferred here? Let's look. In fact, let's sort by size. And we'll look at the very top here. .NET WASM. There's your CLR right there, 756K. And that is the largest file that got downloaded. The rest of these Just assemblies. Yep. Now those are in the browser cache, right? I disabled the cache so we could see exactly what was coming down the wire. But they're in the browser cache, which is managed by the user. So the user can just clear the cache or reload with Control F5. And but if they don't, those things will stay in the cache. And interestingly, look at this. I can click the button, I can click the counter, and no change over here because the code is running in the browser. However, I can still do some cursory debugging. Debugging isn't quite done yet, but I can do that. If I go, I'm in the wrong counter here. If I go to the counter page here and I can put a breakpoint, I can actually hit, because I'm not in debug mode. I can't do that. If I was in debug mode, that would actually hit, but I can't really do much debugging wise, but some things are there, some things are not. Probably in the May drop, there'll be a lot more debugging support. Let me just go ahead and do this again. Press F9. Put a breakpoint there. We're back in debug mode, so everything is getting sent to the browser. The whole enchilada. Here's the counter. Click me. Boom. There it is. And there's another curiosity about Visual Studio. Sometimes you'll lose the color of things that indicate what they are in the editor, and it's fine. Just close the files, load them again, and everybody's happy. There you go. It is preview, after all. All right, going back to the Blazor client hosting model. Benefits and downsides. On the plus side, your code is going to execute more quickly because you don't, first of all, you don't have a round trip to the server just for every UI interaction. Second of all, it's running right there where you are in the browser. You do have offline support. If you make a progressive web application, you can cache data. You can store things to browser, local storage, browser storage, session storage, or local storage. You can distribute these applications with a content delivery network because they're just static files. And as I said before, any .NET Standard 2.0 C# code will run in the browser. So any NuGet packages that are .NET Core 3, those are going to run just fine. Downsides, Blazor client can't directly access your database. In other words, any code that you're running that is secret code, or special code you don't want the user to see, be able to decompile whatever, code that accesses a database directly with a connection string, any code that accesses cloud services that require keys and passwords, you're not going to want to call those from the client. You have to make an API layer to do that. So that's the moral of the story, is that once you get into Blazor WebAssembly, anything that you do that requires access to resources you don't want your client directly to have access to, you have to do that through an API. And here's the thing, I also say your code is shipped to the client, they can see it. Okay, if they want to decompile your assemblies, they can. But here's the thing, the same issue exists with JavaScript. Now, you can minify JavaScript, which makes it impossible to read, but you can also obfuscate DLLs that are sent to the client, which makes it very difficult to understand. But if you really want to, if somebody really wants to, they can look at the JavaScript that is being served, and they can change it and load it and repoint all of the URLs and figure out how to load it, and they can do that. So the moral of the story is, don't write secret code in your UI layer. That's not where it belongs. And WebAssembly is in the same boat as JavaScript. It's running in a sandbox. So it's secure, it's safe. You can't do anything in Blazor WebAssembly that you can't do in JavaScript. Did I say that right? I think I said. You know what I mean, right? So if you can't do it in JavaScript, you also can't do it in Blazor WebAssembly. So let's take a minute and look at some questions here. How stable is the Mono runtime on the client? Is the GC performing well and so on? Yeah, well, it is the CLR. It's the Mono CLR, and it's very mature. So I haven't had any problems running just basic code that couldn't run. You know, most of the quirky stuff is in the preview versions of Visual Studio, but I haven't had any bonks in the browser code itself. Let's see. Personally found all that sort of stuff to be fine. It's debug support that has been the biggest pain for me. Yeah. I'm going to actually show you a technique that you can use today where you can debug your client code by running it on the server. Woohoo! All right. Let's talk about binding. Now, I'm not going to sit here and read this slide to you, but what I will do is go over to Visual Studio and actually show you what's going on in the world of binding. So I'm going to go back to the Blazor server application as the startup project. We're in debug mode, and I'm going to replace index razor, which is just the static page here, with a snippet of code that I've got. Now here's what it is. We have this message. It's a string property. I've initialized it, and I'm binding it to an input. All right. So one-way binding, that's what this is. That's just showing or displaying something. Think of like a label as a one-way binding. But an input or a text box, you might be related to. An input box, you can bind something so that when the text in the box changes, it updates this value right here, message. And that's just the @bind syntax. So let me run this and I'll show you what I mean. @bind is a simplification of the binding, and it assumes that the default property is bound. So I'm going to change this, and it isn't going to update the UI until the default event that triggers that change happens. And that default event is onChanged. So I have to lose focus. So I'm going to hit tab, boom. And now the binding activates and all of the UI, the message changes basically. Now here's a couple of things about this. I can be more explicit by defining the property that I'm binding this message to. And by property, I mean the property of the input tag. So this is doing the same thing as just bind because value is the default property. But if I want to be explicit in what property I'm binding to, you use the dash. Now, we can also change the event that triggers the update, the UI update, or triggers the binding. And that is @bind::event. And I'll set that, by default, it's onChanged. As you saw, I had to tab off and cause that onChange to happen. But I can change that to, say, onInput. OnInput happens with every key press. So now every time I change the input or type a key, it changes with every key press. Pretty good. All right, now we're going to create a component that has a string property, and we'll bind to it. So I'm going to add to my pages a razor component. It's right there in the context menu, razor component. If you can't see that, I'll zoom in. And I'm going to call this child component. I don't know, it just came to me. And here's another undocumented feature of the latest preview of Visual Studio. This is going to just happen eternally if you don't close it and reopen it. So in this component, I've got a div for the UI, and I've just got a little padding around it, and I've changed with a inline style, changed the background color to light gray so that we know this is a component. It's a nice visual cue. I've got a parent message string property. Now, there's this parameter here. I'll talk about that in a second. And also my onClick for the button calls update message. And let's look at that. So update message raises an event that we've defined called message changed. These parameters, or this parameter attribute, says, hey, I want this thing to be a parameter, which means it's exposed to the parent that's calling it. All right, think about it, it's one step above, making a public property or a public event. All right, it's more than that. It can be defined when you instantiate, and it also is a way to wire up events. Look at the event syntax here. Event callback of whatever you want to pass back through the event. Right? There's no event args. There's no ceremony. It's just very simple. So what we're doing when we press the button is we're going to change parent message to Blazor and then raise this event. So we can handle that event in the parent, which passes the parent message. But it's even simpler than that. I don't even have to create a handler for it. Look at this. Back in the parent, we're going to instantiate child component, and we're using binding. We're going to bind the child component's parent message property to our message property, right? Which is also bound in my input box in one-way binding up here. And I'm going to define that the event that triggers that change is message changed. Right? The event of the child component that triggers the change is message changed. So whenever the component raises that message changed event, our message will update because it's bound through parent message. How simple, how elegant. It's beautiful, actually. So here we go. All right, so I'm changing in the input box, changing here in the parent, but also updating in the component. Now from the component, if I change the message, boom, it ripples up and the parent changes as well. I think that's amazingly beautiful. So let's talk about state. Now, by default, when you navigate to a page, the page is initialized, reinitialized, and that means all the page level variables go away. So in the case of the counter, right, this current count is defined in the page itself. So when you navigate home and then navigate to the counter, whatever the value was, it's now 0 again. And by the way, life cycle wise, there are virtual methods in the component model that you can override. There's one that happens when the page is initialized, another one that happens after all the parameters are set. Excuse my nose itches. and then another one that happens after the page renders. But for now, we need to get this, if we want this value to persist between navigations, we want to get it out of here. So what I'm going to do is add a class called appState. It doesn't have to be called appState. That's just what I'm calling it. But just add a class. And anything that you want to persist goes here. So we have just one property, counter. And I'm going to now specify that I want this to load as a service. So I'm in startup CS, and I'm going to add a scoped service of appState. Now what does that do actually? Well, when you add a class as a service, you can add it as a singleton, which means that, like the weather forecast service, which means that one instance is shared among all clients. All right, probably not a good idea for state. That is client specific. Add scoped, which we did here, means that every client gets their own instance, one instance per client. So this manages how this service is going to be accessed. Now all I have to do is inject it wherever I want access to it with the @inject command, data type. There it is. Now this doesn't instantiate it. It just gives me access to whatever instance is defined in the services. So now I can get rid of this line, current count, and I can change that to appState counter. And here, change it to appState counter. Run this again. All right, go to the counter, increment. You can see I'm up to 5 right now. Go to another page. Go to the home page. Do this demo again. Back to counter. It's still 5. And we can still continue to increment it. All right? So now what happens, right? What do you do now? How do I persist that? Like if I just refresh the page, you know, it all goes away anyway. So what if you want to persist that state? Well, you have some options. You can use a document database, right? And take all of that state, serialize it, put it in a document database, and the key would be the user ID, right? We haven't gotten to authentication yet, but needless to say, you have access to the user ID. And you can, once they're authenticated, you go and get their state from that document database, persist it, load it up. Now, I say document database and not SQL Server because it's not really appropriate to use SQL Server for it. First of all, it's more expensive. And second of all, it's not really relational data. You're just getting a chunk of a string, essentially a big string, a JSON string that you're going to deserialize into the state object. Another thing you could do, if the state is kind of small, and Steve Sanderson says maybe 2K is about the limit there, you know, 4K, 5K, whatever, you could store that in the browser's local storage. So you don't have to worry about a server at all. And there's a really good example of it right here in this blog post, the shopping cart stored in local storage. If you just go to blog.appvnext.com, you'll see that blog post, and there's sample code there and everything. It's basically a shopping cart that when you load things into your shopping cart and then close the app, come back in, it reloads from local storage, and you have a timeout. And by default, it's 30 seconds, so you can test it, but you know, you can adjust it to whatever you want. Pretty cool. So moving state outside the server, just like moving SignalR outside the server, frees you up to do what? To make a cluster. So now in between requests, you don't know which machine is handling your request. You don't really care because the machine is getting your state and the signal R is outside. So now you can just get your Kubernetes cluster going and you can scale out, not scaling up, which you would do by adding more memory and CPU. All right, so this is perhaps the coolest thing you're going to see today. I'm going to show you how you can develop both a client, a client and server hosted Blazor application simultaneously at the same time using only one code base. And I'm going to take a sip of coffee first because this is fun. Now I'm not going to read this slide to you. Instead, we're just going to do it. So Steve Sanderson showed off this technique at NDC London. And it was actually Don Webier who was in Steve's advanced Blazor session. I think I was recording a .NET Rocks at the time, so I couldn't see it, but he told me about this thing that Steve had done, and then I did it and I tried it and I was like, oh my God, this is the coolest. And it also solves the debugging issue temporarily. Well, you'll see. What I'm going to do is add a reference from Blazor server. This is my server-side project. I'm going to add a project reference to Blazor WASM client and shared because we need access to that as well. There we go, project references. Now remember this page underscore host CSHTML, right? And you remember this app right here? What did I say about that? That is all of your markup and code in one object. So let's change this from our app to Blazor WASM client app. I'm also going to turn off pre-rendering because there is no such thing as pre-rendering on the client side, and we don't want any differences in the model. So when pre-rendering is on in server-side Blazor, those initialization, the on initialized, on parameter set, those lifecycle virtual methods are run twice. It's rendered once when it's first run, and then rendered again on every client connection. All right, next. Now what we're doing here is we're saying, hey, server-side Blazor, I know you have all these pages over here, but we're not going to run any of these. We're not running our local code. Instead, we're going to use these pages and this code on the server. Okay, so if I want to run both of these at the same time, I have to go to my solution properties and select multiple startup projects. I'm going to select Blazor server and Blazor WASM server. All right, not Blazor WASM client. All right, I want the server that hosts it. I want both of these. And now I'm going to rebuild just because Visual Studio, whatever, might not like the fact what we're doing. There might be some bin and object folders sticking around that don't get overwritten. So when I run this, I'm going to get two browsers. Have two bananas. Two browsers. The one on the left is Blazor WASM. The one on the right is Blazor server. Take a look in the title. There's Blazor WASM up at the top left. There's Blazor server. Now remember, in Blazor server, I had this nice binding demo here. Well, that's not there anymore because we're running the code in the client project. So in the client, everything works just like it did before. There's no difference. And that is called foreshadowing. Counter works over here in the server, but fetch data Boom. First of all, let's take a look at that message. An unhandled exception has occurred. See browser dev tools for details. Now, if this was in release mode, we wouldn't be encouraging the user to see the browser tools for details. We just say an error has occurred, application stops. And by the way, when an application stops, it stops. I can't go anywhere. This is Blazor server, right? I can't do anything. And if you look, I mean, I can look in press F12 and we can see all the errors. And there's a lot of them now because I've started clicking and things. But the big one, the one that started it all, was that the server side doesn't know what systemnet HTTP client is, because it didn't need to. It didn't need to use an HTTP client to fetch data on the server because it wasn't an API call. It was just a local service, a singleton. Remember the weather service? But now it's trying to call into the API. So there's actually two problems here. The first problem is, yeah, it doesn't have that HTTP. First of all, look at fetch data on the server. This is the server-side version of fetch data, and they're a little bit different, right? We're injecting the weather forecast service, which is over here in data. And this is when we're running on the server side only. There's the weather forecast service, and there's the model. And we're just loading it. We're calling get forecast async. This is a local class. We're on the server. But that's not what we're running from the server now. Here's the fetch data from the client, and this is injecting an HTTP client. That's problem one, because we don't have that, because we didn't need it. Problem number two is we're using a relative URL on the client to call into this API controller right here, weather forecast controller. And it's just an API controller. So problem number one, let's solve that. In the server startup, we need to give it access to HTTP client. Okay. So now when that fetch data loads, we can actually inject that because we have access to it. Number two, what is this? We can't use a relative URL. So we have to find the URL of the server app, which really it's localhost, but we really need the SSL port. And that you can find in launch settings JSON under properties. Here it is, 44839. So now we can go to fetch data and make this a fully qualified URL. https://localhost : port number and weather forecast. So with those two fixes in, we can now try this again. Working on your Blazor home automation system. Yeah, definitely. That sounds fun. Okay, now I think this error right here is a ruse. Yeah, integrity attribute. Yeah, I think the key to this is just rebuilding. There it is. So on the client, we have the counter. We can fetch data as we could before. And on the server, we can now fetch data as well. So the moral of the story here is that, yes, the code and markup is the same, but what's different is the environment the code is running in. And that environment has to have the same resources available to it. On the client, right, the resources are loaded in the browser. On the server, they're loaded on the server side, but they have to be there. And included in those resources is JavaScript. So if you put any JavaScript that you want to call through JavaScript interop, which we will talk about, that same JavaScript has to be on both sides. And interestingly, let me just go down a little rabbit hole here. On the server side, that's in _host CSHTML, our old friend that we have modified here. Just put your script right there below the Blazor framework. Call into it. But on the client side, rather, it's here. It's in index.html, which is off the web root. That's where script goes. So, for example, I could write a function called where am I, and in the client side version, I would say you're on the client, and on the server side version, I'd say you're on the server. And then if I call that from each place, I would get a different result because that's in the environment. Okay? So that's in the environment where the code is actually living. Questions on this? Isn't this pretty cool? Powerful, right? Really powerful. The one thing that I didn't show you that's also neat is that when you put breakpoints on this stuff now, and run it from the server, debugging isn't crippled. You get the full ability to examine arrays and step into managed code, things that you can't yet do in debugging this same code if you initiated it from the client. All right? So there's your workaround until May. Okay, let's get back to business. So I'm going to show you a project now called Band Booker, and this is a version, a sort of a scaled down version of the big version that I build in my workshop. I have a 2-day workshop I did for NDC Copenhagen. And this is an expansion of the 1-day workshop that I have online at blazor.appvnext.com. But it's going to be updated to be the full 2-day thing. And this uses all sorts of technologies. And I'm going to show those off. You're going to see code behind. Instead of code in a code block in a Razor page, we're going to move that to a class. You'll see input validation. You'll see JavaScript interop, and I'm going to show you how to make generic components. And also, we're going to look at authentication and authorization. So that is built in. First, what I want to say about auth is that in this latest preview, there's an option in the WebAssembly template to use authentication, just like you can in the Blazor server side. And what that will do is create a database, an ASP.NET identity database, and allow you to call into it. Out of the box, you get what's in the box. You get the UI for registering and logging in. You don't really have a lot of control over where things are stored. But I used this blog post by Chris Sainty to develop the code for Band Booker that does authentication and authorization. And he has sanctioned it for us, for me to use. Of course, it's a blog post, so he just is happy that everybody's reading his blog and using his code. But it uses JOT tokens. And we get a JOT token when we log in. We log in through an API. And the API issues the token. And then on the client, we store that in local storage. And the same code works on Blazor server as it does in Blazor client. So going back a couple of slides, what does Band Booker do? Well, I'm in a 10-piece band, and trying to get 10 musicians to agree to come to rehearsal is hard enough. Try getting them to say yes to a gig. So the problem, of course, is they have no incentive to use this app that I wrote to make it easier for me to book gigs. And the app, basically what it does is we have a gig, I notify the musicians, they go to the app, they say yes or no, they can play the gig. But what they really want to do is just answer my email. And now I have to keep spreadsheets of who's playing what gig, and it's a real pain. So in the big version, I have 5 models. In this version, we're just looking at 2, instruments and musicians. So an instrument has a name, that's it. A musician has a name and a list of instruments. Very simple models. All right, let's take a look at it. I've got it loaded up here, and we are also using the same, technique of building both the client version and the server version at the same time. So I'm just going to run it. Starting with the authentication, you can see if I log out, I get this view right here. Please register to log in to use this app. I can't do anything unless I'm logged in. But if I am logged in, let's go over here where I am logged in. You can see I've got a list of instruments, a list of musicians with CRUD buttons, new, edit, and delete. And the edit and delete buttons are disabled until I actually select something. So now you can see that they are not disabled. If I edit, say, keyboards, this in gray is a component. And the component does the editing, and it also does input validation. So what happens if I make it more than 50 characters, the name is too long. And I can't update. This is what the validation does. Likewise, if I delete, if I don't have anything in the name field, it says the name field is required. And I can't update. So validation, good. Also notice that when I click edit, keyboards is highlighted, so I can just start typing keyboard. All right, that feature doesn't exist in Blazor unless you do JavaScript interop. So I can also click new. Here I've got this input in focus. And of course, if I add the name field is required, there we go. And musicians. Let's go to musicians here. Same thing. I got a name. It's in focus. And I'm going to make a musician Che here that plays congas. And this UI right here is a generic component. So it's a generic component within a component. 2 layers of components. So the musician editor component has all of this stuff in the add button or whatever, cancel button. But from here, all instruments, selected instruments, and this UI, which you've probably done a million times before, right? If you've been a programmer as long as I have, you've probably done this UI, where you have all items in the list on the left, selected items in the list on the right, and now you have buttons for moving things from right to left, and individual things, all things, whatever. So that's the generic component. Now in this version, we're not persisting data to a database, whereas in my version we are. And I have a whole manager and an API layer for that, but we're not doing that here. We're just keeping these things in memory. All right, so that is the app. Let's start, and everything is on index. It's on the main page. So let's start with that. Starting with authorize view. Authorize view is a component built into Blazor, and you can put in the authorized section all the UI that you want to show the user when they have been authorized. And then in not authorized, please register or log in to use this app. Really, really cool. All right, so here you can see I've got a select, which is analogous to a list box, right? Right here. On change occurs when I click on an item. So let me put this here because you don't see any code, right? I've actually done a code behind here. If I press F12, now I'm in index.razor.cs, which I've defined down here. So if you want to move code from a code block into a class file, you create the class file with the same name as the Razor page with a .cs after it. The next thing you have to do is make it a partial class. Otherwise, it couldn't have the same name. And also inherit from component base. And component base is in Microsoft ASP.NET Core Components. And next, any field that you or method that needs to be called from the UI, you have to make protected. At least. You can make it public too, but at least protected. Okay, so where were we? We were in index razor, instrument selected. I have this selected instrument, which I have defined up here as just an instrument. And we're using a little bit of link. We get the change event args out of that select. And args value to string is the ID of the instrument. So then I use a little link to pull that out. And if the selected instrument comes back not null, then I'm disabling, enabling the edit button, which is both the edit and delete buttons. All right, back to the code. I also have this disable instrument list. You'll see that in a minute. And now here's how I'm adding items to the list. I'm just looping for each instrument and instruments. I do a little check here to see if this instrument is the selected instrument, and if it is, I'm using the selected attribute on the option. Otherwise, I'm not. And then the value is the ID, and the text that I'm displaying is the name. And now I have my buttons, and let's look at new instrument button click and follow that down. So here's my new instrument button click. I've got some things. I set the selected instrument to a new instrument, and now I'm calling instrument editor.newInstrument. What's instrument editor? Well, that's a variable name, camel cased reference of instrument editor. Well, where is that set? Right here with @ref. So here I'm defining that component instrument editor, and I say @ref equals instrument editor. And that is this. So where were we? New instrument button click. So now I'm going down into the instrument editor. Let's go there. That is in my shared folder. That's where I put components. So this is the component for the instrument editor, and I have a little Boolean show instrument panel. Turn it on, UI shows. When it's false, you don't see anything. So again, it's a div with the padding and the light gray and all that. And now we have this edit form. And what's that? Well, that's for validation. So, and what's this input text? That is a validation aware version of this. Okay? So the edit form, you define the model, which this is an instance of instrument. Right down there, edit instrument is a new instrument. The data annotations validator says, hey, we want to validate against the annotations on the models themselves. So let's go look at the instrument model. And you can see I've got my data annotations here. That name is a required field, and the maximum length of name is going to be 50. And if we go over 50, it says name is too long. So there's the rule right there on the model. On valid submit. Well, why do we need that? Why can't we just have a submit button? Well, because the edit form here determines that the validation has passed, and therefore, and only then, does it allow you to call submit button pressed. Validation summary shows that those error messages all in one place. There's also ways that you can put them next to each control so you have, a little bit better looking thing. And then my input text, which does the validation. The reason I have this ID equals instrument name is because we're going to call that set focus JavaScript method, and we have to pass the ID of the DOM element for that, because JavaScript DOM elements, right? And I'm binding this to edit instrument name. Here's my submit button, type submit. My cancel button, I have to say, is a type equals button, otherwise it will be considered a submit button also. And now you notice I have events for instrument added, instrument updated, and cancel pressed. So we're raising those events and then letting index do all of the work for handling these things. So look at instrument updated, for example. Instrument updated, instrument added. So this is where, in the real version, I would go to the database API. I would call it an API to add something to the database, or update, or edit, or whatever. Do all my CRUD stuff right here. All right. But as it stands, right now, if we scroll down here to the bottom, on initialized is overridden, and this is where I'm creating my list of instruments and adding guitar, keyboards, bass, drums, and for musicians, I'm adding piano Patty, shredding Shelly, thumping Theo, banging Bob. Right, so there isn't any persistence here, but that's not what it's about. It's about UI. Let's look at the JavaScript interop. This is fun. Remember, we were following our rabbit hole down here. If we have a new instrument button click, right? We'll go there. That calls instrument editor, new instrument. And new instrument sets a Boolean, adding equals true, because this component will work whether we're adding or editing, right? And we want to know which operation we're doing. Also, the submit button text. If we're updating, it's going to say update, and if we're adding, it's going to say add. And then that submit button text is just displayed in the button, the submit button. All right, so now we create a new instrument, we show the instrument panel, and we invoke this JavaScript set focus. And how we're doing that is just, all you have to do is inject an IJS runtime. There it is, and I just called it JS for JavaScript. And so we call await new instrument js.invoke void async. There's also an invoke async of a type, so that defines the type that gets returned. Void because it doesn't return anything. Calling set focus, and we're passing the ID instrument name. All right, let's look at that. So on the client side, remember JavaScript is in web root index HTML. And I've got this script right here defined. And first thing you'll notice is that, wow, that looks overly complex. Here's my window.setFocus, which I'm calling, passing the ID. And now I'm calling this private function with a set timeout of 10 milliseconds, with a timeout of 10 milliseconds. So essentially, in 10 milliseconds, call internal focus. Now, internal focus tries to get an element reference from that ID, but it could be null. Why? Well, hold that thought. We'll come back to that. If it is null, we're going to call ourselves again in another 10 milliseconds and return. Otherwise, we have a reference. We're going to call focus and select. So why did I have to do this null check here? Well, when we call new instrument and we invoke this JavaScript, this is a standard problem that most spas have, right? This edit input text doesn't exist yet. It's not shown, right? Show instrument panel is false. It's not in the DOM yet, and it's not going to be in the DOM until it renders. After it renders, then it will be there. Then I can call focus. Well, Carl, you're thinking, why don't you just do protected override void on after render? Because this is that virtual method that happens after the page has been rendered. Yes, but if I do that right here, I call the JavaScript right there, every time the page is rendered, which means every UI interaction. Now I'm going to set focus. No, it doesn't work. So now I'd have to do a whole bunch of logic to find out when the time is and all that, set a Boolean, yada, yada. And that just smells bad to me. Like that is asking for trouble. So this is actually the proper way to do it in JavaScript. You like? Very cool. All right, cool. And again, you get this, first of all, you get a hands-on lab. Go to blazor-show.com. You can download the hands-on lab to build this application one piece at a time, including the authentication, authorization. And you also get the finished product, which I'm running right here, right now. Okay. So if you're going to deploy, this is just a common sense slide. You want to move your databases to production, and any credential, don't have any URLs hard-coded, move them to config files. You can change those accordingly, according to where you're deploying. But here's the thing. If you're deploying to Azure, if you're deploying a server-side app, right, a Blazor server app to Azure, you have to enable WebSockets. Make sure that's enabled. And I checked, if you just do it from Visual Studio, if you publish and create a new app service, it will, on a Blazor server application, it will actually enable WebSockets for you. It's that smart. But if you're doing it to an existing slot, then you have to watch out for that. Okay, now comes the really fun part. You've seen a lot of code. You've seen a lot of things. I'm going to show you how Developer Express's Blazor controls can save you a lot of time and effort. I'm going to go over to my web browser here and these are the Blazor components. At DevExpress, you can get there by going to the demos online. Just go to demos, and you can see they have all sorts of controls for every platform, everything you can imagine. But if you go to Blazor, you can see there's a whole bunch of demos for charts and grids and the scheduler. Look at the scheduler. Let's look at that. This is so cool. This is like dropping Google Calendar into your application. So I can create things, I can change them, I can move them around, I can overlap them, I can add new appointments, I can edit them. Right? Click here, you get an edit button. Here's all the information for that. Calendars, all of this. Move from one day to another day. Now, this is the coolest part. This is the markup. This is the code. Huh? Talk about getting done. That is just so cool. You can, and that's the whole purpose behind third-party controls. And this is a great example. Is that you're never going to write this yourself. Why would you want to? Right? It's just taking a whole bunch of functionality, like a whole nother app, and just plopping it into your application And that to me is what it's all about. And that's why DevExpress is really, really great for Blazor. Here's just a grid with basic CRUD, and there's all sorts of, other paging, scrolling, master detail view, all sorts of demos here that you can check out. Of course, they're all Bootstrap aware, so you can change the Bootstrap theme if you want to. Now let me show you something else. The guys at DevExpress took my Bandbooker application and said, okay, Carl, that's a lot of code that you got there for basic CRUD operations. Let's see what we can do with the DevExpress grid. And, the grid, as I just showed you, does basic CRUD operations. So it seemed like a good fit. And here it is. So I've got instruments and musicians. I can add a new one or edit or delete any of existing ones. So here I'll create a new instrument, congas, and I can edit any of these, right? I can delete them. And going down to musicians, I'll create a new musician, Che, and then click this guy right here, and I get a drop down for instruments. And of course, if I've already said congas, I can't say congas again. So now I can add or remove from this list whatever I want. So if I can go into Piano Patty, she plays keyboard, obviously. Go back to Che, he's still playing congas and guitar. And I can delete Bang and Bob, whatever, right? CRUD operations. Here's the best part. Let's look at the markup. There's the markup for instruments. How cool is that? Here's the markup for musicians. It's a little more because we had that drop-down list in the form. Let's look at the code. That's all the CRUD code for the instruments. That's all the CRUD code for the musicians. All right, remarkable difference. And yeah, it doesn't have the same look and feel as lists and all that stuff, but it gets the job done. And so if that's your goal, you want to get something out and get it out quickly, this is a really good option for you. Now there's another interesting thing that they do, which is they have a list box. Now remember, I have a list box in, a select, essentially a single select list box in my application. What if I want a multi-select list box? So here is my coronavirus shutdown reading list. These are books that I want to read. Practical Snow Melting for Fun and Profit. That's a good book. How to Shave a Cat. Also something on my reading list. And Winning at Tic-Tac-Toe, because I don't want my pesky kids to beat me at tic-tac-toe all the time. I'm going to show them who's boss. All right, but that's not the point. The point is I want to hold down Control, which I'm doing right now, and select multiple ones of these. I can't do that. Now you would think that I could just go here and say multiple, and that when my book selected is called, when I select something, that this change event args is somehow going to give me access to all of those things that are selected, but that's not the case. It's not there in Blazor. So I went looking on the internets, and I found this guy who wrote a control, and I just realized that I haven't talked about generic controls. I didn't show you the object picker. I'll go back and do that, or we can just look at this, because this is a generic control, and it's called select multiple. And I shamelessly stole it from this guy who has it on a blog post, Ash KE98 on medium.com, and there's the link. Go check him out. And he basically wrote a multi-select list box using a component, a generic component, and this is what makes it generic, type param t item. Now that t item becomes the type or the data type of whatever, in this case books. And he's got some event callbacks and parameters, and he's got some generic stuff to convert by type. And now he's also hooking on after render and doing some JavaScript runtime stuff here, some JavaScript interop. And look at this. This is a JS invocable. So that means we can call it from JavaScript. Let's look and see what he's doing here in JavaScript land. Wow, so that's pretty complex. 3 levels of ifs, some cyclomatic complexity going on here. And he's iterating over the elements, and here he's actually invoking the .NET code. .NET object invoke method async on option select, which is right there. Yeah. So this is pretty complex. It works, right? But this is just indicative of the kind of thing that you have to do just to get some basic controls working. And here's his code right here. I'll hold down Control, and now I can select multiples of that. The markup looks like this. Here's my select multiple. And essentially I've got a selected book IDs, which is a list of string, and I have to use IDs. And I can go through that and pull out the book, and if it's not null, then I show the ID, the title, and the description. All right. So, you know, it's a bit of code. And that's really what I wanted to illustrate, is that sometimes rolling it yourself isn't always the way to go. And so my friend Don Webier from DevExpress is going to come on and show us how to do this the easy way. Take it away, Don.
Hey, Carl.
Hey.
That was a decent amount of work getting that multi-select feature enabled. But fortunately, there are easier ways of doing so by using the native DevExpress Blazor controls. And let me show you how simple that works. I have this page over here, and I have only prepared this property which will hold the selected books of the list box. And what I'm going to do, I'm going to insert the DevExpress list box here, where I will bind the data to the book service, and I'll specify a text field name, which will be in this case the property name, which will be displayed inside the list box. And then the last thing is I'm going to bind the selected items of the list box to the selected books property of the page. And this is basically all we need right now. Let me also include the code that you've seen before. There is one difference though, and that is instead of cycling through this list with IDs and stuff, you can now cycle directly through the selected books collection. And you can write out those property names straight away. So it's again a bit less code here. And once I run the application, let's see what happens now. If I go to the DevExpress demo, what we'll see is that we have the same UI as we had on the previous pages. The only thing right now is that if I hold down the Shift key or the Control key, it still selects one. And that's actually quite simple solved, because right now the list box is in single selection mode. If I go back to the code and I'll add a property which I will change to the list box selection mode multiple, we're all set. So let's run the demo again, and I will now be using my Control and my Shift key as well. And what you'll see is I can select items individually or deselect them, or I can even hold the Shift key to select the whole batch. So that's quite simple, huh?
Yeah.
And there is one more thing I'd like to show, and that is setting another property. And that property is going to be show checkboxes. I'm going to put it to true, And now all of you may guess what this will do. So let's run it again. And what we have now is a really nice list box with checkboxes. And
Very
for
cool.
single selections, I don't even need to hold down the control key. But I can still use the shift key if I want. So if I want to select the whole batch, I'll just hold down the shift. So a very nice and powerful control.
Yeah.
And yeah, if we check the amount of code that was needed to get this desired UI, I would say this is too much, right?
No, it's great. Great stuff. Thanks, Don.
You're welcome, Carl. And we'll talk later.
All right,
Bye.
great. Bye-bye. So there's two ways that you can run DevExpress Blazor demos. Online like I did here, and also you go to this GitHub repo, you can download the source and run it locally, which is cool. There's one demo, the very large data set demo, that doesn't actually run against a very large data set in the online version because it would take too many resources, but you could completely hook it up yourself. To use DevExpress tools, what you really need to do is go to devexpress.com/free Blazor to get these free. You'll be required to, you'll get your own personal URL for a private NuGet feed, and the documentation shows you how to set all that up in Visual Studio. You go to that NuGet feed, you install the NuGet package, and then you modify your HTML header to point to their CSS style sheet, and you add using DevExpress Blazor to your code, and then you're off to the races. Some more resources here you can check out online. A roadmap to keep yourself up on the latest developments, a community portal for Blazor controls, blog posts, new things that are happening, and also don't feel like you can't get in touch with us. Get in touch with me or DevExpress. Go to just Blazor Roadshow at devexpress.com, or Blazor Desk Show at devexpress.com, or just Blazor devexpress.com. We'll get it. So with that, again, I want to thank DevExpress, and I want to thank you for watching me today. And from all of us here, I want to say a fond farewell to you, and make sure that you go and get these tools right here. Thanks very much. And we'll see you out there.